All right, geometry friends, here we go. Welcome to lesson 4.5, angle, angle, side, and angle, side, angle. Okay, so we're working on triangle congruence, and we are looking at simpler ways or shorter ways to prove that two triangles are congruent. So practicing our proofs and our deductive reasoning. And so what we talked about last time was that you don't need all three sides and all three angles to prove triangles are congruent. You could actually use all three sides, just side, side, side was acceptable. And so was side, angle, side. And well, just give it away. That's not all. There are three other ways that you can use to tell that triangles are congruent. And in the questions, I'll kind of give you a clue as to tell, okay, so which ways are allowed and which ways aren't, because they definitely start to look like a jumble of letters after a while when there's so many different ways you can do it. And you might start to think, well, I can do it any three ways I want. No, there's some exceptions to that, and we will cover that in this video. So our first way is ASA, and that just stands for angle, side, angle. And so that is the idea that if we draw two triangles here, there's a beauty, there's a beauty, and we'll call this one, why not, really creative title, ABC, and then DEF. Okay, I can prove those two triangles congruent. Again, just to kind of quickly review, one way we know is as well, what if all the sides are congruent? That would be one way. Or we learned, what if the two of the sides are congruent and the angle in between, that side, angle, side, that would work. But this way is simply if I have an angle and then I have another angle and I know the side in between. So not only can you do side, angle, side, you can use angle, side, angle. And so that would be enough to prove that triangle ABC is congruent to triangle DEF. Okay, so side, angle, side is acceptable. And again, notice it means the S is between the two angles. Okay, and then we have another combination, and that is angle, angle, side. So as I kind of just said, well, don't draw that quite like that. Let's do something more like this. If I have two triangles, and this time we'll do something like, let's go with GHI, JKL. Another combination that works is if I know two angles, so those two angles, this one and this one, and then the side that comes either before or after it. So it could be this one, because that would be angle, angle, side. But just so you know, this is the same as, and I'll put it up here, this is the same as side, angle, angle. So there is no difference in the order. So whether it's the ones I did there, or you could also just as easily say this side is congruent. Either one of those, the combination would prove that these triangles have to be congruent. There's no way you could draw two triangles with two congruent angles and then a congruent side and not have the rest of it fixed and know that the two triangles are exactly alike. So in this case, triangle GHI is in fact congruent to triangle JKL. All right, so angle, side, angle, and angle, angle, side work. Then we have this thing called HL. And HL is a special case using right triangles. Okay, so in order to use HL, that stands for hypotenuse leg. And just remember, the only kind of triangle that has a hypotenuse is a right triangle. Again, every triangle has a longest side, but that's not called the hypotenuse unless it's in a right triangle. So what hypotenuse leg says is that if you have a right triangle, and so first of all, it has to be a right triangle. So let's get that in there. If you know that the hypotenuses are congruent, and you know at least one leg is congruent, okay, then those two are in fact congruent triangles. And let's go ahead and call them M, N, O, and P, Q, R. Okay, so it's unlike all the others. All the others have three, and so does hypotenuse leg. But if again, you only need two sides, and you have to know it's a right triangle. And so we'll talk about in a minute. This is not called angle side side because it's not any angle. It has to be a right triangle. So it's hypotenuse leg theorem. And so that is the triangle MNO is congruent to triangle PQR. And so there still is 3 pieces of information here, just like all the others. You got the 2 sides. One has to be a hypotenuse, one has to be the leg, and then you have the right angle. Notice it does not mean you cannot do this. It cannot just be the 2 legs. That's not HL. Now, are those triangles congruent? Yes, they are, because look, you have side, angle, side. 2 sides with an angle in between. So those triangles are congruent, but if you're doing a proof, you wouldn't want to say HL, you'd want to say side, angle, side. However, for HL, it has to, one of the sides has to be the hypotenuse. And of course, they have to be right triangles. Okay? All right, let's move on to the questions then. So general question. So what theorems can be used to prove triangles congruent? What theorems cannot be used to prove triangles congruent? And the easiest way that I'll demonstrate this is I'll start with the can't. There's 2 ways you cannot. In other words, if you take any combination of 3 sides and angles, there's only 2 that will not work. The one is all angles. Angle, angle, angle. Okay, that will not work because you could do something like this. Just as an example, I could draw a nice little, let's just say that's a equilateral triangle, equal angular, all 60 degrees. Well, I could draw same thing, but much bigger, but that angles can still be 60, 60, 60, and yet these are not congruent. So knowing 3 congruent angles definitely does not prove triangles congruent, because you could take that same shape with the same angles and you can blow it up bigger or smaller. And so there's no guarantee that those are the same size. So that's one you cannot use. The other one you cannot use is the bad word. Okay, but I'm not going to write that because Jesus. Whoops, that's not right. Yeah, I don't even want to write the bad word. But it's SSA or ASS. All right, no donkeys. No donkeys in geometry because just the way I remember it is that it's a bad word. So that's the other type you cannot use. This one, it's a little tougher to demonstrate, but you could have a triangle here with the same side lengths and then maybe the same angle at the top, something like that. But then you could, if you don't know the angle in there, you could still change the angle and you could have something like this. And so those angles roughly could be about the same size, same length of the side lengths, yet because this angle right here can hinge in different directions, there's no guarantee that those triangles are going to be exact congruent. Now, that's not a very great drawing there, but just remember, the bad word doesn't work, and neither does the AAA. Okay, so there's 2 that don't work. So that means any other combination you can think of is permissible. So there's lots of ways to prove triangles congruent. That's SSS. Okay, all 3 sides. That's SAS, side, angle, side. Those were from last lesson. And then, of course, the ones we talked about today. Angle, side, angle. Or angle, angle, side. Notice that is not a bad word. So you can use 2 angles in one side. You just can't use 2 sides and 1 angle. Okay. And then added to all of this is the one that doesn't quite fit in, but the special right triangle is then HL. So you've got 5 possible ways, combinations to prove triangles congruent, and 2 possible combinations that don't work. Okay. So watch out for those. Number 3. Number 3 asks, let me see, I think I got this right. Sorry. Let me click real quick. Number 3 asks, how is HL like SSA? What type of angle will it always include? Okay. So if you actually look at this, I've got 2 triangles here, and they're proven by HL because I've got the hypotenuse congruent, I've got the leg, and I've got the right angle. If you actually write these out in order, you can see this is actually side, side, angle. Okay, and if you remember, that looks like the bad word. So just looking at counting out the angles in order, it looks like this shouldn't work. So the point is the bad word one, SSA or ASS, doesn't work except when you're dealing with right triangles, okay? So it still orders it in the same order, but it works in the specific case of a right triangle. So you could kind of say that SSA only works if, and that's a big if, the angle is 90 degrees. Because then it uses HL. Okay, so just trying to point out that HL is kind of an exception to the fact that ASS doesn't work. But you can just kind of forget that. ASS doesn't work. Just remember a right angle can work if it's HL. Okay, and again, a lot of these questions, they'll make more sense as you start to do the proofs and you get more experience with working with these combinations. Okay, number 4. Number 4 asks, this gets into the clue domain. We talked about clues in the last video. What does it mean when they give you parallel lines, or what does it mean when they give you a bisector? A little clue to HL is how do they give you a right triangle? Because, again, you can only use HL if you have a right triangle, and you can only have a right triangle what usually gives you a right triangle. So there's two primary ways. One simple way that you can know a triangle is right is if they just say the angle equals 90 degrees. Okay, or they might even do something, say it's a right angle. Okay, so that's not real brain science, but just that's one very simple way. If you get in a given such and such angle is 90 degrees, you want to think, they told me there's a 90-degree right angle. It means I have a right triangle. That means I could probably use HL in this proof. Okay, the less indirect way, the less direct, more indirect way is they will tell you that two lines are perpendicular. Okay, because that's a clue. If they tell you these two lines are perpendicular, well, what does that mean? Oh, that means that you have a right angle, and if you have a right angle, that means you have a right triangle, and if you have a right triangle, then that means you can probably use the HL theorem. So again, one of a more obvious clue, the fact that you have a 90-degree angle. The other more indirect clue is if they tell you you have perpendicular lines. It doesn't all guarantee you're going to use HL, but it should be a definite send alarms and, okay, oh, I got perpendicular lines. That means I've got a right angle, right triangles. I'm probably going to use HL. Okay, let's get on to number 5. Number 5 is just a proof practice. We're going to do 250, page 257, number 12 out of the book, just to practice a full triangle proof together. All righty. So let's take a look at what they've done. And in this particular problem, the given, they don't give us an explicit given. They just give us a given with the markings. So let's go ahead and take a deep dive into that. Put my little dividing line here. And so what did they give us? Well, what they gave us was that we have sets of parallel lines. Okay, they have told us, let's go big red, according to this, RU is parallel to ST. How do I know that? It was marked, so that counts as given. And so now you should immediately go, parallel lines. That means transversal, alternate interior angles. So let's take a look at that. I'm going to mark this up and then erase it just so you can see. And this is where you want to be a little careful. We said that is RU is parallel to ST. Where's the transversal that connects the two lines and the two triangles? The triangles, by the way, are RST. So this guy right here, and we're trying to prove him congruent to RTU right there. Okay. Well, let's look. Here's the transversal right there. Okay, so where are the alternate interior angles? And I can't do it on the screen, but I might even turn the picture to kind of look at it how I'm used to looking at a transversal. And I can see between these three blue lines, my alternate interior angle is here and here. So that means those two angles, since the lines are parallel, those two angles must be congruent. Okay, and so let's name that. Top angle is URT. So angle URT is congruent to angle STU. I'm sorry, whoops, STR. All right, so angle STR. How did I know that? They are alternate interior angles. Okay, so once you have a set of parallel lines, you very likely have a transversal, and then you look for the alternate interior angles. And so now we know that we've got one set of congruent angles. Okay, so now let's see. Oh, there's actually two sets of parallel lines. I'm gonna have to scroll up just a little bit, see if we can squeeze this in here. And we can see that RS, I'll scroll down, RS is parallel to UT. Okay, and that is given. That was in the drawing. Alrighty, so that means I'm going to do a different color here. So we've got this one right here is parallel to this one right here, and the same line acts as our transversal. Okay, so looking at that, where are my alternate interior angles? Well, in this case, it would be this angle and this angle. Those are my alternate interior angles, just looking at the green. Okay, so that means I've got another set of congruent angles, and their names are, let's see, angle SRT is congruent to angle UTR. UTR. It's getting a little messy there, but we'll figure it out. How did I know that? Again, alternate interior angles. So that means now I've got a set of congruent angles here and here. So that means I've got two. Usually you need three pieces, you know, SSS, SAS, AAS, etc., etc. I have two angles. So that means I'm only one piece of information away from proving these triangles congruent. I've used my two given, so there must be some other clue here as to what makes these triangles congruent. And I asked you in the last lesson, one of the clues is what happens, look for when the triangles share a side. If the triangles share a side, such as this, what does that mean? Well, that means that that side of each triangle must be the same because it's the exact same side. So I know that this right here is congruent. And I know it's getting a little covered up, but that's RT. So I know that RT is congruent to RT. And do you remember the reason for that? You just kind of reflexively know that it's true. I'm going to extend my divider here. All right, so yeah, that's reflexive. So have I done enough? Well, let's check what we have. We have, let's see, we have an angle, side, angle. It's because we found two angles are congruent and one side is congruent. Three pieces of information, it should be enough. And it is angle, side, angle. You just look at the order of the, that's why, again, I highly recommend, you got to mark up your drawings when you do proofs. It'll make your life so much easier. Angle, side, angle. So that means I can do what I call the finishing move. I know that, let's get the names of the triangles. What are they? RST and TUR. I know that triangle RST is congruent to triangle TUR. And what's my reason? Angle, side, angle, because that's the order, and that's we found two angles on the side, and it was the side between the two angles. So we're done. We did it. Okay, notice much shorter. We didn't have to prove all the sides, didn't have to prove all the angles. It wasn't angle, angle, side, not allowed. It wasn't side, side, angle, not allowed. That's a bad word, or at least an annoying donkey. So it works. Alrighty, so there's an example using clues, looking at the drawing. And again, don't be frightened if it's difficult. You just do more and more of these together and you will get the hang of it, and you will get pretty good, and it will end, and we'll eventually move on to something else. So if you hate it, there's light at the end of the tunnel. All right, see you soon in class. Looking forward to helping you as much as I can.